This is part 2 of section 9.7, solving quadratic inequalities. The first thing we need to do is we need to have a 0. And we're going to end up needing to factor, so you want this p squared to be positive. So I'm going to subtract 2 from both sides and get 9p squared plus 3p minus 2 is less than 0. Okay? Now, once you have it like this, then we need to factor this as much as possible. So think through your factoring. Do we have a GCF? No. I have a perfect square here, but 2 is not a perfect square. So I'm going to be looking for two numbers that multiply to a negative 18 and add to a positive 3. And that would be 6 and negative 3. Yes. Okay, so I rewrite this as 9p squared minus 3p plus 6p minus 2 is less than 0. Okay, now add your grouping symbols and factor what you can. From the first group, I can factor out a 3 and a p. And that leaves 3p minus 1. And from your second group, you can factor out a 2, leaving 3p minus 1. And that's less than 0. Now factor out the 3p minus 1. And you have 3p plus 2 less than 0. Okay, now to figure out what goes on my number line, I need to set each of these equal to 0. So 3p minus 1 equals 0, and 3p plus 2 equals 0. Let's solve these. Subtract 1 from each side here. No, add 1 to each side here, and I'm going to subtract 2 from each side here. So I get 3p equals 1, and 3p equals negative 2. Now divide both sides by a 3. And you get p is 1/3 and p is negative 2/3. So those values are the ones I'm going to put on my number line. Make sure that they are in order. Okay, now extend these down so you have a chart. Okay, now over here, I'm going to put these factors right here. And now I just need to find some test numbers. So I need a number in this region, and this region. I need a number smaller than negative 2/3. Well, negative 1 works. I need a number between negative 2 and 1/3. Well, I have a negative and a positive, therefore there is a 0 between them. And I need a number larger than 1/3, and I can use 1 for that. Now imagine taking this and plugging it in here. This would be negative 3 minus 1, which is negative. This would be negative 3 plus 2, which is negative. Now plug in the 0. 0, 3 times 0 is 0. 0 minus 1 is negative. 0 plus 2 is positive. Okay, now plug in a 1. 3 minus 1 is positive. 3 plus 2 is positive. All right, so that's the chart filled out. Now remember, what we've got is two things multiplied together, and we know their signs in each region. A negative times a negative is positive. Well, a negative times a positive is negative. Positive times positive is positive. Okay, so we have our chart filled out. This much would be needs to be done no matter what. Okay, so now we need to decide whether or not we're supposed to be greater than or less than 0. I look right here where we have the 0, or I could have looked up here before we factored it. Either way, we want our answer to be smaller than 0. So we're wanting our negative answer. And our graph is negative between here and here. Okay? So I know on my number line, I'm going to have negative 2/3. And I'm going to have positive 1/3. And my answer is between them. I need to decide what goes here and here. This is a simple less than with no equal to on it. So these are parentheses. And then your answer in interval notation will be negative 2/3 and 1/3. Okay, so let's try 6x squared plus x is greater than or equal to 1. Okay, so the first thing we need is a 0. So I'm going to subtract 1 from each side. And that gives me 6x squared plus x minus 1 is greater than or equal to 0. Okay, now I need to get this thing factored. And so I look at this, I do not have a GCF, I don't have perfect squares, so I'm going to be looking for two numbers that multiply to 6 times negative 1, so negative 6, and that add to a positive 1, and that's going to be positive 3 and negative 2. So I rewrite this as 6x squared minus 2x plus 3x minus 1 is greater than or equal to 0. Okay. Now group. From the first group, I can factor out a 2x, and that leaves 3x minus 1. And from the second group, I can't really factor out anything, but we have to factor out something, so factor out a 1. Greater than or equal to 0. So this overall factors as 3x minus 1 times 2x plus 1 is greater than or equal to 0. Now set each of these equal to 0 to find out what goes on the number line. Okay. So here add 1 to both sides, here subtract 1 from both sides. 3x is equal to 1, 2x is equal to negative 1. Divide both sides by a 3 here, and by a 2 here. And you'll see that x is 1/3 or x is 1/2. So those are the values that are going to go on my chart. Okay, so now I'm going to put my factors over here on the left. So that's 3x minus 1 and then 2x plus 1 and make it into a chart. Now I need some test numbers. I need a number smaller than negative 1/2, so I can use negative 1. I need a number between negative 1/2 and 1/3, a negative and a positive, so there's a 0 between. I need a number larger than 1/3, so I can use 1. Now imagine plugging these numbers in here. This would be negative 3 minus 1, which is negative. Negative 2 plus 1 is negative. 0 minus 1 is negative. 0 plus 1 is positive. 3 minus 1 is positive. 2 plus 1 is positive. Now at this point, you may be wondering if all of your graphs are going to be identical, and the answer is definitely no. Okay, it happens a lot, but it doesn't always happen. Negative times a negative is positive. Negative times a positive is negative. Positive times a positive is positive. Okay, now what are we looking for? We're looking for this thing to be greater than or equal to 0. So I'm interested in where this thing is positive now, and it's positive here and here. So I have two distinct regions where my answer is positive. So I'm going to have on my graph, I'm going to have, see, I have negative 1/2 here, I have 1/3 here, and I'm shading this way and this way. My graph goes off in two directions because there are two regions that work. Now what goes on these values here? Well, this has an equal to on it, so these get brackets. Now pull your interval notation off of this. This one starts at negative infinity, and infinities always get parentheses. And this stops at negative 1/2 with a bracket. Now since there are two regions, we use a union symbol between them. and then you have bracket 1/3 up to positive infinity. And that's your answer for that problem.